Okay. So the goal I set for my students was for 70% of them to know what causes earthquakes, what faults are, and the names of different types of faults. While this was a lot to accomplish during one lesson, I believe that my students could because they had mastered different plate boundaries before, and faults are a variation on plate boundaries. On the last exit slip on plate boundaries, 86 out of 114, or 76% of my students, could correctly name the plate boundaries and the movements that cause them, so they had a very good understanding. I believe that they would be able to apply this previous knowledge into the new information they were getting about faults. In addition, we had gone over what earthquakes are briefly in previous classes, and students could say that plate boundaries create earthquakes when I asked them what plate boundaries, one of the things plate boundaries makes. Marzano believes that students can handle up to 3 chunks and choose in a lesson, so I thought I could use earthquakes and faults as 2 chunks during my lesson. Because using arrows and hand signs worked so well teaching plate boundaries, I believe that my students could use these same strategies. So I had them draw arrows on graphic organizers as well as illustrate the different faults with blocks of wood so they could use their hands and visuals to represent the new faults and movements that they were learning. I had students in the beginning when they sat down fill in their learning logs to see if they had any, or if they believed they had any prior information on this standard as soon as they sat down. By thinking about what they might already know, students were able to prime their brains in order to receive new information on the topic. Surprisingly, my students mostly put down that they would get these questions correct a little less than half of the time. Because we had never gone over anything in this learning target, it seemed that they were overconfident going to this lesson, and it became clear quickly that they had had no practice with faults by how they were answering questions wrong during the beginning of the lesson. But they did begin to improve after practicing. For my hook, I asked kids if they had been or seen a car accident, and then they explained to me what happened to these cars, which got the class very interested, because most of them had been in or seen a car accident. For the IBE, we watched 3 different videos of car accidents, and while they were watching the videos, I had them write down what plate movements they think these different videos could link to. Each one did link to a different type of plate boundary. And after that, I had them do a think, pair, share with the people around them to see what answers they come up with, and also to see how the car crashes could represent the results of plate boundaries. Most of them were able to say which car accident compared to what was going on, but only about a third of them came up with the idea that these accidents could be similar to earthquakes. Although the lesson plan called for students to take notes on the material and think, pair, share after each new fault introduction on the cars, I realized quickly I was not going to have enough time. So by my second period, I decided to have students use the blocks to figure out the actions of the faults for themselves before I revealed the answer to them, and this would be an active practice. So students use the blocks to move them and figure out what type and then they would describe to me how the faults were looking. And I said yes, and we would call that a reverse fault, or something like that. And students would then fill in their graphic organizer by drawing pictures in and describing that fault movement. Sadly, I only had time for this active practice and not a guided practice at the end because notes took so long, and I think this affected the students' assessments because students did not have enough time to digest the material. I had a lot of think, pair, shares still though, when they were figuring out the different movements for the faults for themselves. And because I learned during observing Claire's class and during our discussions in our methods class that students often remember things better after they've explained it to each other and tried to figure out material on their own in groups first. Also, Chris Symes, who's a practice math teacher, believes strongly in students figuring out the material for themselves, and then you reveal the scientific names for them at the end. So by the end of all my lessons, kids were getting much better at that. Or I was getting much better at teaching them too. But they were definitely starting to understand that, like plates could go down and one's going up. They were clearly seeing that movement. Sadly, students did not do very well on these exit slips. Only 34 out of 114 got all 4 questions correct. 52 out of 114 got like 3 out of 4 questions correct, and the rest got 2 or less correct. The breakdown of scores were pretty predictable, with my advanced learners getting all fours on the questions right. My medium learners had about 75% getting threes and 25% getting twos. And my lower learners and English language learners together got about 80% of them with twos, and the other 20% got ones. Sadly, all of my sped kids got ones and zeros, which definitely shows that I did not differentiate this lesson enough. Even though I had tried to have them draw more pictures, I definitely need to think of another strategy that will help them learn it. I think my failure to reach my goal is partly because my questions were strangely worded at the end, but mostly I think it's because I tried to do way too much in one lesson. I quickly realized what I thought was 2 chunks was actually like 5, and so that was much too much to do in one sitting. In reflection, I found as well that a coworker who teaches the same thing, or taught the same thing as I did, found that do nows will actually really help kids increase retention. So for my next do nows, I'm going to have the same questions or similar questions to go over, and we can relearn the material that way, as well as keep bringing in the idea of faults as we continue to discuss earthquakes. This worked very well for my coworker, whose test averages went from 56% to 78% after she started doing this practice. And looking at the people's quizzes, after my students' quizzes at the end, they put a number between 1 and 4 how confident they felt, and most of it matched up to around the score that they got, although if anything, kids were a little overconfident, especially my medium learners. Definitely thought they got 1 or 2 more questions right than they actually did.